Hey, how's it going? How's it going? This is Mr. Hernandez, and I'm going to be going over this first unit with the study guide for the first semester, which is on polynomials. So the first thing we're going to do is talk about different parts of the graph of a polynomial. The first one is zeros, and zeros is another word for x-intercepts. So if we look at this graph here, this is the x-axis going across here, and this red graph is going through the x-axis at 1, 2, 3 different points. So those would be our x-intercepts. This one looks like it's at -3. This one looks like it's at -1. And then this one is at 2. And so we're just going to pretty much write in those 3 x-intercepts. Now, the x-intercepts are going to help us determine the factors. So because there's 3 x-intercepts, there's going to be 3 factors. And the main thing to remember here is that the signs of each of these x-intercepts will be the opposite of the factors. So we're going to have x plus 3, x plus 1, and x minus 2 being in factored form. We could write y equals or f of x equals, same thing. Now, polynomials are the ones that have arrows going both directions, left and right. And so the domain, that is what the domain is asking, is the distance left and right, which are the x values. And in this case, it's going to be all real numbers because it goes left and right forever. Now the range is going to be the up and down direction, which are the y values. In this case, it looks like this graph does go up forever, but the furthest down it goes is down here. So that'll be the lowest point. That is called the minimum. And if we look at the y-axis, this would be -8.4 here on the y-axis, and that's as far down as it goes. So there's a couple of ways of writing the range with that. You could say it goes from -8.4 to infinity, or you can say that it's x is greater than or equal to -8.4. Those are both saying the same thing. Okay, the end behavior, this is x approaching -infinity, which means the left direction. So what's the left direction doing? It is going up. So this would be positive infinity. F of x would be positive infinity if it goes up forever, negative infinity if it goes down forever. And so in this case, we are going to be positive. It will be positive infinity or just infinity. It's the same thing. And then this is the right side. Fx is going to positive infinity. That's the right arrow. And the right arrow is also going up. So f of x here would also be positive infinity. So there's a maximum right here. This would be the max. And so that would be 0.2, 6.2. There's no other bump going up and down besides this one, so there's no relative. We could basically say it's the same thing, though. That's totally fine. We could just write it as both. The minimum is, there's 2 minimums. There's this minimum, which is the absolute minimum, because that's the lowest. But then there's this one over here, that is the relative minimum, because it's relative to the left and right side. It is the lower point because it goes down and up from there. So that would be relative. Okay. So increasing would be from left to right, going up. And so if we're looking at this graph, It goes down, up, down, up. And so I'm going to go ahead and label the decreasing intervals in red. And then from left to right it goes up. So this would be an increasing interval. This would be another decreasing interval. And then finally the increasing. So this first increasing interval is this first blue one, which starts at the x value of negative 2.2 and the x value of 0.2. So the intervals always use the x values. So this would be from negative 2.2 all the way to 3.2. The next increasing segment starts at the x value of 2 and goes to the right forever. So that'll be 2 to infinity. Okay, the decreasing interval would be this one. So this one goes from negative infinity all the way to negative 2.2. And there's another decreasing interval from this x value of 0.2 all the way to this x value of 2. Okay, so when you're talking about number 2, when you're talking about determining the end behavior, you're talking about either odd, either the exponent is odd or even. And so the highest exponent would be this 5 here, and that is an odd exponent. So odd odd polynomials, the arrows either go left and right, or down and up, or up and down. They go in opposite directions for odd degrees. So notice they're both, one's pointing up, one's pointing down on each of these. But if it's an even, if this highest exponent, if this degree was an even number, like 2, 4, 6, 8, then you'd have the arrows either both going up or both going down. And so here we know at least that it's odd, so we could look at this here. And then the other thing would be if the if the leading coefficient was positive or negative. In this case, it's negative. So negative values, the right side goes down. So if it was a negative even, it would be this one here. This one would be the negative even because the right side goes down. This is a negative odd because the right side goes down. So this would be our answer. This is the combination of being negative and odd. So if we look at the arrows, this this is the left arrow, x approaching negative infinity, and we can see the left arrow is going up. So this would be f of x going to positive. This would be the right arrow, and in this case the right arrow is going down, so f of x would be negative infinity. That means going down. Okay, so that's the front. The back starts at number 3. Whenever you have a negative between two parentheses, you could consider that a -1 multiplying to that second parenthesis. And what that's going to do is switch the signs of each of those numbers in the parentheses. So this would go from 3x cubed to -3x cubed. This one's already negative, so we're going to make that one positive. So we're going to switch that. And this just basically is multiplying. A negative times a positive is a negative times a negative is a positive, a negative times a positive. That'll switch this from a +9 to a -9. So that's why we switch the signs, because you're distributing that negative, multiplying. These will just be brought down, and we're going to look at like terms now. So this is a quadratic term, x squared. There's another quadratic term, and I think this one should be a 3. Yeah, this one was a third, right? So let me just take that back. This one should be 3x to the third, negative 3x to the third. And so that one is not going to combine with this 2x squared. It'll be this one that's going to combine with it. So that'll be what, 2 plus 3 is 5x squared. Now this has the highest exponent, so I'm going to just write that first. Usually you write the highest exponent first, and if there's no sign between them, you could put a plus. Okay, so now we're looking for linear terms to combine. There's no x values that are just linear terms, but there are these two constant terms without any variables. So we're going to combine a positive 7 and a negative 9, which would be a negative 2. So this would be your final answer for number 3. Okay, number 4, we could pretty much just ignore this plus. We could just start combining like terms. So what I'm going to do is just, rewrite these numbers over here underneath the ones that are going to combine with it. So this would be lined up here, taking these numbers over here, terms, and writing them under their like terms. So this would be 9x squared plus 4x minus 10. So when you're adding or subtracting, you're just combining the coefficients and leaving the x with the exponent the same. Same thing here. Okay, so now we're going to be multiplying. And I'm pretty sure this goes over here for this one. So I'm going to rewrite this over here. Okay. Okay, so I'm going to go ahead and distribute this x into these two terms, and that'll be let's see, x times 3x squared is 3x to the third power. We're going to add 1 degree here, and this is a Ninja 1 here, so we could add the 1 and the 2 to get 3. X to the 1 times negative 9x is negative 9x squared. So in this case, we could just add the 1 and the 1. That's the product rule to get 2. Okay, now we're going to distribute this negative 5 into these two terms. So negative 5 times 3x squared is a negative 15x squared. Negative 5 times negative 9 is a positive 45. And then because this has an x, we're going to go ahead and just put that x here. And then you can use this this box here to set up your using the box method of multiplying. But I'm going to go ahead and put the answer, let's say I'm going to put it underneath. So this 3x squared is just going to get brought down, or 3x to the third. This negative 9x squared and negative 15x squared will be combining to give you a negative 24x squared. And then the positive 45x will just be brought down. And that'll be it. If you wanted to use the box method, you could set it up this way. I'll set it up for you. So this first binomial could be written this way, x minus 5. And then this second binomial could be written over here, 3x squared minus 9x. And then you'd end up getting 4 terms, just like we had 4 terms. These two terms right here would combine just like these two terms, and you still get that there. Okay, so if we do that again, I guess I could do the box method here. Let's go with 3x plus 7, and then 2x squared minus 4x. So this would be where the 2 and the 3 multiply, which would be 6. And then you use the product rule, which is adding the exponents, x to the 1 times, or plus x to this, or you're basically adding these exponents to get a 3. Same thing here, negative 4 would be multiplying the 3 on this one. negative 12. And then here we'd have x squared because of the x to the 1 times x to the 1 is x to the 2. You're going to add these exponents when you're multiplying. That's the product rule. Here, right here, we're going to multiply 2 and 7, which would give you 14. And then we're just going to carry down the x squared. Because there's no x here, we're just going to bring this right here. And then 7 times negative 4 would be negative 28x. And then we could see that these are both like terms, so we're going to combine those two. But there's no like term for this term, so we're going to write that first. Then we're going to combine these two to get positive 2. Those are different signs, so we're going to subtract, take the sign of the bigger number, and then this one's going to be brought down last. And that's it. For number 6. Okay, number 7. We have to determine if x minus 4 is a factor. And so we're going to definitely want to change this, change the sign of the x minus 4. And that'll tell us, that'll be positive 4. And then we're going to set up these coefficients for negative 13, negative 5, and negative 28. We're going to write those coefficients just right here. And now we have our synthetic division problem set up for us. The first step with the synthetic division is to just bring down that first number. And then we're going to multiply 4 times 4 is 16. And then we're going to combine these two, negative 13 and 16, to get us a positive 3. Then we're going to multiply this 4 again to this 3 now, which is 12. And then if you combine these two, these are different signs, so we're going to subtract, take the sign of the bigger number, so we have a positive 7. And then we're going to multiply again. 4 times 7 is 28. And because these are both different signs, positive and negative, we get a 0. And 0 is a good thing. No remainder means that this is a factor. The other number left out is x plus 2. So we could change the sign there. This would be a positive 2. Oh, I'm sorry. This is actually x plus 2. And so we change the sign to make that a negative 2. Okay, so just want to make sure I'm setting it up right. And then we can set up our division problem. We're going to take the same coefficients here. So this would be 4, negative 13, negative 5, and negative 28. Okay, first thing we're going to do is bring that down. Then we're going to start multiplying. Negative 13 and negative 8 is negative 21. Multiply again. 42. Okay, that's going to be subtracting. So what's that, 37? Multiply again. And then that'll be, what's that, 1474 and a negative. So this is going to be definitely not 0. What are we going to have left? 8, 9, 10, 11, 12, 102. Well, this is a remainder, which is not good. That tells us that this is not a factor. Okay, well, I hope that helps you out. Stay tuned for Unit 2 of the study guide.